Welcome everyone. For today's prep, we're going to start to look at graphing polar curves and polar regions. And we're going to start today with the two most basic types of polar curves, and then we'll also see an example of a polar region. So let's look at the first two examples. So the two most basic types of polar curves are where we take our r variable and set it equal to a constant, and then the other side of that is what happens if we take our theta variable and set that equal to a constant. All right, so let's start with r equals 2. Let's start with this polar curve. So we want to graph this. So what this is saying is essentially what we're trying to do here is we're trying to find all of the points that have a polar representation where the r coordinate is equal to 2. So if r is equal to 2, this is telling us that the distance, remember r is the distance between our point and the origin, well, the distance between our point and the origin should be equal to 2. So this is describing all points that are 2 units away from the origin. All right, well, if that's the case, we have a way to kind of have that idea already. So this is telling us we're dealing with a circle of radius 2, centered at the origin. So let's graph that. So we know where our origin is. There it is. And we want to go 2 units away. So we count 1 unit away from the origin, 2 units away from the origin, and we're going to be considering all of those points that sit on that circle. All right. Ooh, I don't want it filled in. Filled in, that's a polar region. Let me get rid of the fill there. So we just want to go all the way around the circle, but it's just that single curve. So this is r equals 2. It's all the points that are on that circle. It's not the points that are inside. So we're just looking at the points that just sit on the edge of this circle here. Okay. Now what about a polar curve that's in the form theta equals a constant? So in this case, we'll see theta equals pi over 6. And let me, let me get out of the way here. All right, so we want to find essentially all the points that have a polar representation where their theta coordinate is pi over 6. So first of all, let's find the pi over 6 ray. And here it is. So pi over 6 is in the first quadrant there. And it's this kind of the shallow one of our principal angles. And what we're doing is we're trying to find all the points that have this as their angle measurement. So all of the points sitting on this ray here have a theta value of pi over 6. And that includes the origin, because the origin can really have any angle just so long as the r value is 0. So all of these points here satisfy this equation. Well, we're only interested in the angle here. So r could potentially be negative. So not only are we allowing points in the positive direction on this, but we could potentially have points going in the negative direction. So this is also included on the graph of this polar curve. So when we do this, we're kind of splitting up our polar curve, and you want to think of it when it's theta equal to a constant, you kind of want to break this into kind of 3 separate sections. So we've got the section of positive r values. So there's the positive r direction this way. There's the negative r direction going this way. And then there's r equals 0 right in the middle. So what we're seeing here is when theta is equal to a constant, well, then we're just getting the entire line going through the origin that matches up with that ray on the positive part. So this is just giving us a line through the origin. Okay. So those are the two. We're going to be, in the next section, we'll be looking at more kind of exotic types of polar curves. But these are the two most basic ones, where we set r equal to a constant, and that's just giving us a circle, and then theta equal to a constant, and that's just giving us a line segment, or a line. So let's look at polar region. And we'll start with, we're just going to do the first one here. So what we want to do is we want to figure out, we want to sketch the part of the plane where we have points that satisfy both of these inequalities simultaneously. So we want to find all the different, so if we're looking at the plane, we've got all these points on there. And we want to find all of the r values, or we want to find all the points where they have a polar representation where r can be between 0 and 2. And theta is between 0 and 3 pi over 4. So when we do these polar regions, a lot of times it's helpful, start with the angles. So first of all, what does it mean when theta is equal to 0? Well, theta equal to 0 is our positive x-axis that matches up with there. So we're going to start by... Let's draw theta, make this green. Let's do theta equals 0. And we're just going to keep, because the r values are positive, let's just draw the positive section of that ray. Okay. So there is theta equals 0. So that's the one edge. Now we want to go to the other edge and look at theta equals 3 pi over 4. So where is 3 pi over 4? Well, we know pi over 4 splits the first quadrant in half. So 2 pi over 4 is the positive y-axis, and then 3 pi over 4 splits the second quadrant into half. So 3 pi over 4 is going to go kind of right in the middle here. All right. So we've got theta equal to 3 pi over 4 here. So we know where we're kind of starting and where our region is going to end. So we've got the two kind of edges. And now what we're going to imagine is we're going to imagine kind of a rotation counterclockwise. So if remember, when we're dealing in polar coordinates, we're going counterclockwise around the origin here. So we're going to start with theta equals 0. And let's look at now this inequality where we're going, the r value goes from 0 to 2. So the r value going from 0 to 2, well, we're going to be at the origin. That's r equals 0. And then at most, we're going to go to r equals 2. So that's going to take us to this section right here. And so we end up with this section of our x-axis, or we end up with this little section here. And what we're going to do is we're going to imagine taking this and kind of like a radar thing, we're going to imagine that just rotating counterclockwise around the origin. And we're going to see what section of our plane that this little slice traces out. So we're going to start sweeping it. It's going to go around. It's going to go around. We're going clockwise, clockwise, counterclockwise, 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 and then we stop here. So when we trace this around, what we end up with is the r equals 2 section of this inequality traces out the outer edge. R equals 0 is just kind of stuck at the origin. And we end up with all of these points in the middle here. So we not only do we end up with the points on the edges, but we also end up with all the points inside the middle here. So what we're doing is, again, we're starting at our starting ray, theta equals 0, and then we're only looking at the section of that ray where r is between 0 and 2. And then theta equals 3 pi over 4 tells us where we're stopping. So we let this just kind of sweep around. And we're going counterclockwise, so we're just letting it sweep around. And then it tells us our ending ray. And we end up with a polar region. So a lot of these polar regions are going to look like wedges or kind of parts of donuts. So we'll see a few more examples of this in class. So we'll see you then. Bye-bye.